fangen wir an. Hello and welcome back
Hi guys.
to another nice Twitch stream with Andreas and Backend, of course. So what are we doing today?
Today we want to have a look at Quarkus, obviously, and we want to look at gRPC within Quarkus. So as always, there's an extension in Quarkus to handle gRPC stuff, and yeah, we want to have a look at that, see how it's working, what's the current state of the implementation, and so on.
Okay, what's gRPC?
Yeah, gRPC is basically a way to define your APIs like REST or GraphQL, but it uses a different format.
Okay.
Instead of normal HTTP calls with like JSON or so, it uses protobuffers. It's also stuff from Google, where and protobuffer allow you to store the data in binary format.
Okay.
The data of your messages that you send around.
Mm-hmm.
And since it's binary format, it's much smaller than JSON, for example. Because in JSON, you always have the schema also in the message, because you send the object and you always have like name equals Hans and and so on. So you also you always have the schema with you in the message.
Okay.
But if you would define the schema ahead of time and tell your client, hey, that's the schema.
Mm-hmm.
That's exactly how it looks like, the binary message. Then you can just give that to the client. The client knows how to interpret your message, and you don't have to send it alone. So you can really shrink down protobuffer messages are much smaller than JSON. So that's one benefit. Another benefit is gRPC really uses the advantages of HTTP2.
Okay.
So one benefit of HTTP2 is that you can keep a connection open all the time.
Mm-hmm.
So when I do multiple calls to the backend, in old HTTP, you open a connection for every call. And if you have HTTPS, then you make 3 round trips just to find your encryption key for this transmission and so on. So this takes a long while, and you do this for every connection.
Okay.
In HTTP2, you basically open that connection one time and you send everything over that connection. And the server also sends back all the stuff over that connection. And it makes it much easier to stream data to the client and back, also from the client to the gateway. So you can really do a lot of fun stuff with that.
Okay.
Yeah, that's the good side. The bad side, tool integration, yeah, the stuff comes from SeaWorld. And yeah, tool integration with stuff like that is often not as perfect yet. So we will have a look at that too.
Okay.
Yeah. So let's have a look. When we want to get started with Quarkus and gRPC, we can just have a look at the documentation here. As always, if you just Google Quarkus gRPC or Quarkus something, you find the docs. What we see here, we need the gRPC extension. So let's just start with a fresh new project. And how would you create a new project? You go to code.quarkus.io. Very simple. And here you have a configurator where you can configure your initial project start. So I'd like to use not Maven, Gradle. You can just select this.
You're not using Gradle with Kotlin, you're using Gradle with Groovy, right?
Yeah, I'm more used to it.
Okay.
Yeah, I haven't found or I haven't had the need to really look into with Kotlin stuff, so I didn't get started with it yet.
Okay.
But you can use it as well. You can select here. So the Java version 17 is the most modern that they really support. And now we can add extensions. So we want to have gRPC, obviously. And we want to use Kotlin. So 2 ticks, click on it, download the zip file, and extract it, and start it in your IDE.
So there's also a CLI tool or a CI tool. Just saw that you can say Quarkus dev, or what was that? When you
website Quarkus.
Yeah, when you clicked on the generate your application,
Yes.
you had a
Yeah. They also have a Quarkus CLI tool.
Okay.
That's right. That you can install.
Mm-hmm.
And with that, you can also just generate projects. You can start the project with this command.
Mm-hmm.
And that takes care of handling if it's Maven or Gradle and just runs the right command.
Okay.
So you don't have to know that you have to do this with Gradle and something else with Maven. But yeah, I haven't had the need for it yet.
All right. But this will not include the dependencies you just selected, right?
This is only to start the project after I have extracted it.
Okay.
But
okay.
it's not actually generating the project.
Okay.
But you can also do that with the CLI.
Oh, okay.
But usually, like clicking here is easier than specifying. There you have to specify like Quarkus minus Kotlin and so on.
Okay. And it's prettier.
Yeah, it's prettier.
Nice.
Yeah.
Okay.
Pretty is always good. Oh, half the wild. It's gRPC. Google Remote Procedure Call. Yeah. The idea, to go back to that, is when you have REST, the idea is to make resource-based calls. And when you do RPC, remote procedure calls, then it's really like calling functions. So the same way you would call a function in your own code, you can basically call a function on the server. But yeah, we have generated a project, and we have opened it, and that's the project. It's basically empty. It has a Docker file that we won't need, and yeah.
Can you increase the font size?
Oh yeah, as always. What? Font editor. Yeah, at least for the editor.
Oh, okay. Yeah.
I really have to check how to increase it also for the IDE. Yes. So we have the basic setup. What we got is basically by making these ticks. The generator has added Quarkus gRPC. Arc is always in there. We have added gRPC, and we have added the Kotlin extension and the Kotlin standard library.
Okay.
So now we want to start with gRPC. And the idea of gRPC is that you have some protobuffer proto files that you use to describe your API. And from that, you generate the code and the server or the client.
Okay.
So we start with defining such a service. For that, we have to create a proto directory under main here. It's basically where we will put the proto files. And we put in create service proto. Oops. Alt-tabbing. So first we have to do some boilerplate. We want to do a proto 3 file, so there's 3 different versions. And even with the 3rd version, they didn't get rid of the semicolon. So already you see the C world.
How up to date is Proto 3?
It's the newest, but I don't know by heart when it was created. It's a couple of years old, the whole Proto thing. So it is already quite, I think, 10 years old, the original idea, but it only now gets some traction in real adaptation. Google uses it for a long time internally, but now more and more companies adopt it internally. First, we need to define our package where we want to have our generated code. So Proto supports different compilers that generate you this code. And the Java compiler supports this Java package option. And so we can specify this. If you have a Swift compiler, then probably you need some other options. So much for the boilerplate for now. Let's define the service. So we want to have a greeter service. Let's call it greeter. And now we add methods to it. Like I said, it's remote procedure calls. So we define the procedures that we can call. And so we define an RPC call, say hello world. We always have to specify a request and a response. So here we have the hello world request, and it returns the hello world response. Very creative naming. And that's basically the service definition. Now we need to define the request and the response. And these are called messages. We have the hello world request, where we have a string name, and we have semicolons. And we have message, hello world response, string message. So here you already see a specialty of protobuffers. It's this equals 1. If I add the next string, surname, I have to do this. And so on. And like street, this is now number 3. And yeah, I'm
interesting.
I'm creating an example.
So this is not to assign the name to 1. It's more like kind of an address or kind of a numbering system.
It's the first thing that will come in the binary format. And this is important for when you want to upgrade the API, or when you want to make non-breaking changes. So for example, if I now decide the street and the number, I don't want that anymore separate. I want like street with number. I can now say this is 5. And I can remove these 2.
That sounds terrible. So if you have, after a while, if you have changed the schema for many times and you see, okay, there are a lot of numbers missing.
2,500.
And then what would be, so the highest number should always be on top then? So if you have something new, and you always have to make sure, okay, you have to be higher than the number which was on top?
You may never reuse an old number, because then it will replace basically this part in the message. It's not like it keeps that space open. It's just important for the format, so they can then write in the message something like, okay, next is 5, the 5th thing. And this is, you may not reuse these, because the good thing is this is generated code later on. So the server that produces this message is generated, and the client is generated. So you don't have to ever touch these bytes. That's the
Okay.
only way this can work. But yeah, the good thing is I can make a non-breaking API change.
Mm-hmm.
I can replace this basically. It's
Okay.
also
As long as you count upwards, and what do you normally do? You just uncomment the lines you used before and you don't want to use again, or do you delete them?
I think you can say reserved 3 or so. Yeah. And reserved 4. And when you would now reuse, so yeah, then it complains 3 and 4, they are already blocked. You may
Okay.
not use them. So I would replace it like this, probably.
But then you don't really know what 3 and 4 was before, right?
Yeah, but you don't need it either anymore. So
Okay.
this is the new API.
You will never use it again. Okay? Okay. Oh, okay.
Go back to Git history if you need to know.
Okay.
Don't leave old code in your code base. That's what you have Git for. Yeah. One downside is to make this totally painless for everybody to upgrade and not a breaking change.
Mm-hmm.
You cannot have required fields. All of them are optional.
Okay.
That's a change from Proto 2 to Proto 3.
Mm-hmm.
In Proto 2, you had required and optional fields. In Proto 3, everything is optional. I don't like that change.
Okay.
Because it does not allow me to say I always need a name.
Mm-hmm.
Instead, I always have to check myself, is the name set or not?
Okay.
And yeah, that's a bit of a pain.
So when you use it in an app, for example, you would have the first transition would be something where everything is optional. And then you would have something where you actually have the required properties non-optional, so you can make sure that they're not all optional, but you actually have the object you need, right?
Yeah.
Okay.
And that's a real pain because you have to do this checking on your own. And if you think back when we used gRPC, I can define my Kotlin data class, and I say this is not optional, and gRPC just checks it and throws a bad request if it's not there.
Okay.
So I don't have to handle it manually. Their argument was if you have to handle it manually, then it's your problem and not the protocol's problem.
Okay.
And I don't really like that perspective on things.
Yeah.
I think the protocol should allow you to handle this and rather provide a good mechanism to make breaking API changes. But they are on the side of making a very lightweight protocol that doesn't support you too much, and therefore is simpler to implement and so on.
Okay.
A nice thing is you can also, for example, there's C compilers, for example, to make from this a C client.
Okay.
And in a private project, I used it to make one Arduino project where I have defined my message. And now I send data with gRPC, which is really small, and I can send it over LoRaWAN, which is a IoT protocol, which is very limited in the number of bytes you can send. So you really get down to only what you need. And in the server, I can just use this message, generate my Java code, and decode it.
Okay.
That's a nice thing. So you can really bridge between different technologies with generated code.
Okay. But you always have to make sure that the client will also understand what you're doing, right? So you have to have the hello world request also has to be defined in the client so he knows what to send.
Yeah, ideally, I share this file with the client and they generate their client code from it.
Okay.
So what you can do is put these definitions in a repository and then in your service somehow include them or whatever. And also in the client include them, and there in the project you can run the Swift Proto C compiler or the Java or C, or whatever.
Okay.
And then generate the client code from it.
Okay. So, and if anyone catches the call in between, you can't read it without having the schema, for example, right?
Yeah, you need a schema to understand the bytes properly.
Okay. Mm-hmm.
I mean, if you really look at it, you probably can also find out because it has some tricks to minimize data usage and so on.
Okay.
So, for example, there's I think there's int64.
Mm-hmm.
But it, in best case, if you have a small number,
Mm-hmm.
it only uses a single byte
Mm-hmm.
on transmit.
Okay.
In the worst case, it uses like 5 bytes or so. Or no, 64, then 9 bytes or so. Because so normally for a 64-bit number, you would need 8 bytes,
Mm-hmm.
but always 8 bytes. And what they do is they use the first bit in every byte to say, and if it's a 1, then another byte is coming that belongs to this number. And the remaining
okay.
7 bits are only used to represent the number.
Mm-hmm.
So you can basically chain them, or you chain the bytes. And if you have a number like 10, then you only need, you can fit it in 7 bits.
Mm-hmm.
So the first bit will be 0, and then you have the 8 or whatever in the remaining 7 bits. And if you have a number like 128, then you would need 8 bits.
Mm-hmm.
So you need 2 bytes then, because you only have 7 bits in the first byte.
Okay. Gotcha.
But with that, you have dynamic size, and they really shrink down how much traffic you need, or
Okay.
how big the message will become. So there's some logic in there and some byte moving and stuff.
Okay.
So you would not want to do that code on your own.
Okay.
Yeah. So that's that. We have defined our protofile. So if we want to continue with Quarkus and really work with that, what we do is we click on run, or make Gradle W assemble or so.
Mm-hmm.
And basically we just trigger the build process, and this will trigger the code generation. Let's see if we process resources, Quarkus generate code. Probably it's in here. Unable to start. Oh, I still have it running. So, what this causes is in the build directory up here, which is super small for you to see.
Mm-hmm.
I
think it's appearance, right? No, wait, it's all editor tools. Yeah.
It was.
Ooh, nice.
Okay. In the build directory, we have classes.
Mm-hmm.
In here we have Quarkus
Generated sources, okay.
Yeah, but it's in here actually.
Whoa. Okay.
It's also in here. So, but this is probably just IntelliJ shows it in this way.
Okay.
But actually it's in here. So for our Krita service, all these classes have been generated by Quarkus.
Okay.
So
And
first,
those are all it's interface. Okay.
interfaces
okay.
and some implementations with some specialties and so on.
Mm.
So the first interface here extends Mutiny service. And if you remember from our sessions, I once told that there's this thing called Mutiny,
Mm-hmm.
which is basically the Java RX of Quarkus. It's a bit different, but it's basically their reactive framework.
Mm-hmm.
And here you see you have a method. It's called, say, hello world. It has a parameter, hello world request, and it returns a uni of hello world response. And a uni is basically something that can be deferred or happen in the future, like also Java 8 futures,
Mm-hmm.
or
Okay.
promise in TypeScript, stuff like that.
Okay.
And they have a whole API set where you can chain stuff and so on. So there's uni and there's multi.
Okay.
Multi is for giving back a stream. Okay. Then we have a greeter bean.
Can you close the console down below so we have a little bit more space?
Yeah.
Yes, perfect.
I have the greeter bean. This is a bean that is also obviously all generated. And this is later used from Quarkus to then call the implementation of the greeter interface. So this is just some boilerplate for Quarkus. We already have a client. Quarkus directly generated a client. And here we have the say hello world method where we can pass in a request. And we get back a hello world response again as a uni. And we can just inject this somewhere in our service and then call it.
Okay.
So that's the nice thing. So there's automatically generated, and basically you would do the same in the client and like mobile or so, or in another service.
Okay.
Then we have greeter gRPC, which so you see there's this is like super ugly generated code. Yeah, the details are not so important. I think in here we have probably...
Will this grow when you have more than one property on your... Okay.
Response, hello world response or builder. I want only the hello world response. Here. So here we have the hello world response. And yeah, it has the message property. And then you always get a builder function and so on. You will see how we create an instance.
Okay.
The good thing is you don't have to look at this. We just did it for the fun. What we can now do to use it, we create a Kotlin class. Let me just create a package. And a Kotlin file, and we name it greeter service. So here we now need to implement this interface. So we need to be a greeter, and we need to type Quarkus. This is a gRPC service. And obviously we need to implement the say hello world method. And
this is what he gets from the classes he created himself, right?
Yeah, the greeter was this interface that we looked at in the beginning.
Okay.
Cool. Okay. Is it maybe? See, let's call it like that.
I could be that greeter service already taken. Yeah.
Collision. Let's wait for the rebuild. Yeah, because they call it greeter service in here, and yeah.
Well, it's a service and it's a greeter, so it's a greeter service. Okay.
Yeah.
Got it. Okay. But this could also, like in Swift, we have different things, so we can have implementation or impl.
Yeah.
For this one, so okay, basically the same.
Yeah.
You just have to rename it.
Just a naming conflict here now. You could also use the fully qualified name here, or name the import, but yeah.
Okay.
Better like that, before we have to look at too many import stuff. So now in here we have the hello world request. It will always be there. The question mark is only there because we use a Java interface and we generated a Kotlin method from it. So it says like, okay, in Java, you never know if it's null or not. So to be safe, we make a question mark. But in gRPC, you always have to provide a request and a response. So even if you don't send something back, or you don't send a request, you need to provide an empty message.
Okay.
So we want to return.
So you wouldn't leave the optional value as a request in, and then just if it's empty, then resend a response, an empty response. But you would rather have it this way, right?
Yes, because I know it will not be null.
Okay.
So that's why I make this go away, so that I don't have to check it and stuff, because I know it won't happen.
Okay.
The framework ensures that. It's just,
okay.
The gRPC client or server that is generated makes sure there is always this object.
Okay.
So now we have to work with Mutiny. We have to create a uni. Create from item. And now we need to provide that item. We don't really do something asynchronous here.
Okay.
So that's why it looks even more crazy to have this chaining and stuff. But you could maybe call it database and then follow up on that. So it's basically like promises or so, or RX, if you know that.
Okay.
With this chaining, then you can here chain or map, and then on item or on failure, do something, subscribe to it and stuff.
Okay.
You can also emit on, which means you switch the thread pool basically. At the moment, we are running on the event loop. And you should never block the event loop. That's one of the most important things, because then you will starve your whole server. So you can, for blocking stuff, you can switch to a thread pool, idle thread pool, where you could do blocking stuff. Yeah. So we create this item, and we do this by saying we want hello world response. We need a new builder from it, and then we need to set the message. But if we do it like that, then we cannot access the builder afterwards anymore. So I do apply, like a nice Kotlin function. Apply makes it that I have now in this body, this is the Krita service builder, or the hello world response builder.
Okay.
So in here, instead of, I can now write this dot message or just message. It's like if I would be in there.
Okay.
So now we can set a message, hello world request dot name. And we have to build the whole thing. And you already see this doesn't really look like nice code, maybe like that. I would really prefer to have data classes instead of these builder things, because data classes basically work like builders. Unfortunately, Quarkus does not have a Kotlin implementation at the moment for the gRPC stuff.
Okay.
So there's generators that generate Kotlin code, but at the moment they only support the Java generators and the generators to create this uni stuff. Ideally, this would be a suspend function, a Kotlin suspend function, and I can just return the hello world response, and I can work completely in the Kotlin way, and I would get data classes instead of these builders, and live a happy life.
Okay.
At the moment, it looks like this.
Okay.
Okay. So that's our first gRPC say hello world service.
Nice. So now the big question is, this is a coded message you will receive and you will send back, right? So how do you test this?
Exactly. how can we test a gRPC service? And that's really nice. There's a couple of tools that allow this, and gRPC has this introspection, reflection. I think they call it reflection. And basically they expose this proto file on an endpoint.
Okay.
So if you have a smart client, it can read this and provide you the API dynamically. What is a smart client? Well,
so you don't have to share the proto file. You have to actually call the correct endpoint to get the proto file somehow?
You can do both.
Okay.
So if I just want to see what my server can handle, I can use this reflection. But it's the same as if I would share the proto file. Okay. So having the proto file in a repository and then injecting it into your build process is probably a better way to directly use it. But if you use a third-party API, it might be that they provide you the proto files via this reflection call.
Okay. How many proto files do you get from this reflection call? Do you just get one because you have to specify it for, or do you get all of them?
No idea. I never called it myself.
Okay.
You will get the stuff probably in binary format or so. We just want to use it. So we again use Postman.
Okay.
Important, it needs to be a gRPC collection. So
what's...
you cannot, I will delete this just for testing. Okay. The easiest way I found is not making a collection, but creating a gRPC request first. Because if you create a normal collection, then you cannot add this request there. No idea why. Okay. No idea why. So in here, we just enter localhost 9000. So you might remember from Chuck's and stuff, Quarkus usually runs on 8080, port 8080.
Yeah.
The gRPC server is actually a different server that runs in parallel on port 9000.
Okay.
They are working on integrating it with the normal Vertex server, because Vertex can also handle gRPC.
Okay.
But some features are missing, and so they try to get feature parity there. And then they will switch to the normal Vertex integration.
Oh, okay.
So here we can now select the method, and it already did the reflection. We can also refresh it here if we add something new. And we see we have the say hello.
Can you switch back to JetBrains to see what the... So they must have done one call, right?
Yeah. That's auto-generated, that call. You don't see that.
Oh, you don't see it. Okay.
Nice thing. Here you can click on this, and you can also generate calls from within IntelliJ. It also has an HTTP client. You can script it there.
Okay.
So it could be helpful for tests also. But also with Postman you can make tests.
Okay, so when you typed in the URL, Postman actually did a request to the URL to find out what does the server can do, but all of the server, right? It's just not one endpoint, it's all the server. Okay.
So if you have a private and a public API, you probably don't want to expose this.
Can you manipulate it so that you don't expose it?
There's a property.
Okay. No, don't worry about it. Just, okay. Yeah. But it's still, okay.
So we can now just select the say hello world. And unfortunately, Postman does not generate example message. Just discovered a nice feature. I was always wondering why does it not generate it. But yeah, that's also good. And now we can send this, and we get hello world ut cons whatever. Let's go to a more reasonable name. And I've just demonstrated a bug that I found earlier. I'm not sure if it's Quarkus or Postman.
So you sent a new request, right?
Yeah, I sent a new request.
But you still get the old answer.
Yeah.
Interesting.
But the interesting thing is, Quarkus does not receive a new request. It receives the same old thing. So I think it's a Postman bug, because if I send it now, then it's working. And if I'm fast, then it's not updating or always too late.
Huh.
But if I wait a bit, then it works. So I think Postman does not refresh what it's sending when you click the invoke button or something like that.
Huh, interesting.
Yeah, so probably it's just a bug in Postman at the moment. I will later have to try with a different client to see if there's different clients to see if that works with them, or if it's actually a Quarkus bug maybe. But from the behavior, I suspect it's just a Postman bug.
But there's no caching or anything.
No.
Okay.
We don't have that stuff activated.
Well, it could have been that gRPC is also some kind of magic all-wonder solution, so that it.
Yeah, I actually created a logger. And now in here we could do request.name. And one more thing, the hot code reloading doesn't work too good with gRPC stuff yet. So normally when you have Quarkus dev running, you just change something, you make the next call. Usually you get some exception when you do this with gRPC. So there's some work.
Well, does it understand that you only change the implementation, not the proto?
Yeah, it understands that.
But it still hasn't.
Something of the class reloading and so on failed.
Okay, perfect.
I also don't know if it's only Kotlin or also in Java, because with Kotlin it's always a bit trickier for them. But I haven't tested it with Java because I just don't want to code Java if I can avoid it.
Sure.
So if we now do this and we see it was the wrong response, we also see here that we received the wrong request.
Interesting.
So I really suspect that
Postman is doing something wrong.
Postman is only refreshing this every so often internally and not when you click invoke. And then if you're fast, then...
I've never seen this problem with normal REST.
I think it's an issue with the gRPC integration. I mean...
Interesting.
Yeah.
Yeah.
So, but now, this is our first... Almost throw down my bottle. This is our first gRPC service. It's very simple, and you can view it here in like JSON, in human readable, but over the wire, it would only send this string on the first place of the binary data.
So the main advantage of gRPC is that traffic is lower?
Yeah, you have less traffic. It's also faster because you don't need to build all these big strings. I mean, before you send the JSON, you first have to create all the JSON thing.
So it's only faster in sending it, right? It's not like... I know that in some project we have to have the gRPC library in the mobile client, and that takes a long time. So the server side is really fast.
The build process takes a long time, right?
Okay.
Yeah, so probably you should have the library somehow pre-built or so. Because there is quite some code in that library, because it needs to deserialize all this byte stuff, all this byte mess. Like I said before, if the first bit on a number is set on the byte, then there's another byte and stuff like that.
Okay.
But the good thing is these byte manipulations, they can be implemented really fast, especially on low-level clients.
Okay.
This is really something, byte manipulation, something every CPU can do really good. So if you have this well implemented, then it's also the parsing is really fast, parsing and writing these messages. So you have less load and less traffic. That's an advantage. And you have an exact typing, if we don't talk about the optional thing. But this defines my API.
Okay.
I can give you this, you generate your client, and you call a method. So what I can do here is, you shouldn't call it in here, but I can, no, constructor, I can just in gRPC client, create a client, client, and I could now in here would be a self-referencing, but I can do say hello world. No, I need to put in a request object and have to build it with the builder and stuff.
Okay.
Hello world request new builder apply name gleich name equals and then build. Yeah. And this gives back a uni. So, but with this, I could call this service now.
Okay. Where's the response going to be sent to? To the person who made the call?
Yeah. Or if I do this, here's like.
So I send a request, and the request is sending another request to the server.
This makes no sense to do.
Okay. No, just checking. So it will actually return the response to the one who sent it, right? So the sender would actually receive two responses, right?
This now would end up in an indefinite loop.
Oh, okay. Oh, true. Yeah, sure. Okay,
because I called myself again, just with a remote procedure call with some HTTP in between. But this would end in an endless loop if I do it like that. But what we could do is add like rest easy reactive common then JSON or JSON parsing. Yeah, hopefully that works. And now we could make a REST service. Create REST. Oops. Yeah, create is not synced yet, so it doesn't know that I added the dependency. Get greeting. I'm eyeballing this now, so bear with me. It's all just because Moritz is asking so many questions. Hey. What's your meeting? And in here we inject that client. So now we have this client in here. Yeah, no, it is okay. Here we could now return a uni of data. Greeting response. Message. That's it. Of the greeting response. This is my REST response. Just to make sure it's or to verify or show that's something different. Here we can do the say hello world. We put in a request. Our request is the hello world request. New builder equals name. Shadowing and build, and this is gRPC response. You see it's the uni, the hello world response. And we can now return the gRPC response and map it first to a greeting response DTO and hit dot message, put that in here. So we map it over to a Kotlin data class. And what's wrong with you? Okay. There's one thing. Of course, we also need to tell the client where to, yeah, it needs to be a gRPC client. And then we also need to tell it where the server is.
Okay.
It needs to know where you want to call it, obviously. So what we can do is this, and this hello is the name used in the gRPC client annotation. Okay, so we can make this, no, not here, read the rest. We can call this my gRPC, so whatever. It's just a name, so you can configure different ones. Clients my gRPC is localhost, and probably can also add the 9000 or 9000 is the default. And now let's see.
So now you wrap the gRPC client around the REST API endpoint?
Yeah. So basically, I simulate what I would do when I have a REST API, and I need to call a gRPC API. But instead of calling some other gRPC API, I call myself. Good. Come on. gRPC client. I'm not doing so much differently here.
I think you missed the name, right? Yeah.
The name?
No, don't. The REST query is the part where you actually export the name.
Yeah, how I provide a name.
Okay, yeah.
Can it be injected into Beta REST? Only mutinies. It's blocking. Okay. What if we do it like this? So if this works now, this will be the next ticket I open.
So the problem is when you create the REST API itself, it will. Okay, never mind.
Okay, something I have to check. But you see, probably it's some stupid mistake because they do the same, or what is this? Element values. It's really interesting. I have to test this again. Sorry, guys.
No worries.
But let's get back to gRPC.
Yeah.
I want to show you another cool feature of gRPC. It has streaming support. Let's make a timer service for fun. And we call this get time. Time request response. Some time. There's also there's no long. It's int 64. It's even unsigned int. That's something they support. Yeah, here for now we said nothing. Okay.
Okay.
Again, run it once to get rid of this board break stuff. Run it once to generate. And then we can
probably
make the
remove some dependencies, right?
gRPC. They don't matter.
Okay.
If you don't use them, Quarkus removes them automatically in the build process.
Nice.
And gRPC service. And no, extend timer. Yeah. That's the interface again that we have to implement. And now
okay.
our function. And I did not add everything that I wanted. This would again be the same. We get a request, we return a response. But we want to return a stream of responses. There's also repeated. There you can return an array. But we want to return a stream. We built it once, and now this is a multi. So, and what this does is we can now send multiple responses here. Create from ticks every seconds 2. So we basically, with this, we create a multi that basically one message flows through it every 2 seconds.
Okay.
And now we map this, probably it's just the number. Actually, I don't know what is in here. Would need to check the every, but in the end we don't care. We want to return get time responses. So first of all, we want to have the date, the current. Yeah, so let's just create a date. So after this, if you do if you check, we have now a multi of date. And now we can map this again and say we want to have a get time response. Again, new builder, apply, and then time equals it time. Returns the number of milliseconds. Awesome.
And this is also a uint, or what does the dot time return?
Sorry, what do you mean?
The it.time.
It is the date that we pass.
Yes, but dot time, this is now, what kind of number is it? Because you said it's supposed to be in unsigned int. 64.
Yeah, that's the number of milliseconds since January 1st, 1970.
Okay. No, okay.
So it would not be, yeah, so we know it's a uint because we always generate a new date.
Okay.
So it cannot be before 1970.
Okay.
In that case, it makes sense. If you would just return the date from database like this, you shouldn't probably use that format. There's also in gRPC, in protobuffer, there's a format for time stamp.
Okay. So it doesn't matter that this one is long and not an unsigned init.
There's no unsigned int in Java.
Okay, so that's the long. Okay.
Yeah.
Okay. Perfect.
Now we can just return this, or we can also directly return this thing here. And let's remove this question mark here and run it again. So now up here, updated reflection. We have a new service, new method.
Time.
We have now get time. Generate example message.
Now it also says timer.
Yeah.
So you can have
our timer service.
So you do get a lot more information from the server.
You get the whole thing here.
Okay.
This reflection gives you the whole thing with all the
Okay.
naming and with the DTOs and stuff. So it knows it all.
Okay.
Otherwise, it could not decode it anyways if it doesn't know the
Yeah.
messages and stuff.
Mm-hmm.
So, and now you see
Interesting.
every like 2 seconds here, we get another one. And if we check here, yeah, the fourth number from the right.
You could have formatted it as a string to get back so that
Yeah,
you see it, but
I
it's
could
fine.
have.
Can you zoom in a little bit, because I think
Oh.
this is a pretty small, maybe? I don't know. Can't you do Command plus?
No, I don't think Postman supports this.
Not on Windows, I guess.
It does it on...
Ooh.
Really?
Yes, it does.
Next time I will just increase the scaling of my... make whole Windows grandpa
That's
friendly.
cheating.
But it works.
Yeah,
Just
of
have
course,
to know
of
how
course
you
it
do
does.
it.
Okay. Yeah, but nice.
Another thing, if we cancel it, then it will stop, obviously, here.
Okay.
But also in our service, we now don't have a log, but we could add like logging here. So where's my logger? Logger info again. Maybe you could do it here and print it. Let's see what it is. And when you close the connection, then obviously this multi will also be closed and this whole thing will turn off. Just want to show you that it's real. Again, 0, 1. Yeah, so it's just counting the every.
Okay. Yeah,
the first parameter you
every duration of
it's
seconds.
just
Okay.
counting, so it's 6, 1 or so. Yeah, and when we cancel this here, then it's done here. And there's also like on termination or on completion call something. So you can also make like, oh, when it's closing, then do something else.
Can you, will the client receive, so can you do, when the client closes a connection, can you still send like, okay, a bye or something to the client? I don't know, just...
I know too little about the Mutiny APIs. They are a bit special. I prefer to avoid them. But if you want to do stuff like that, really with the streaming, then it's at the moment probably your best bet to go with it. With Kotlin, maybe I show this the next time, we made some helper functions that can get you a coroutine flow or a Kotlin flow from the multi and to the multi, and then you can work with flows.
Okay.
But you need some boilerplate code around it. And ideally, Quarkus would want they just provide the generation for that.
Okay.
Yeah.
Nice. So what would you need the multi for? Like, I guess it's, for example, when I hear stream, I think audio video, but this is not for audio and video, right? So this would be...
It's a stream of data. It's a stream of get time responses.
So something you need, if you need more than, or if you will request it and then you will get more, like, for example, stock prices or whatever. Something that you always...
You could subscribe to stock prices, or you could make a super simple chat system.
Mm-hmm.
If we go here, we can also make this a stream. And if we then generate the code, then we have also a multi here. And then we can subscribe to that request multi and do on item, call something, map this. And so
okay.
you have a bidirectional stream now, or connection now.
Okay.
And I can send a chat message and you can respond to chat messages from the others or so. That's something you could do.
But this would be only from one endpoint to the other. So you would connect actually two clients to this, not multiple clients to one person, right?
Yeah, first of all, it's just client to server.
Okay.
And then you would need to put it in a database and subscribe to the database also.
Okay.
But that's what you could do. You could subscribe in here. So on every request, you could put it into the database.
Mm-hmm.
And when this method is called, you subscribe to the database.
Mm-hmm.
So for example, with Postgres, you can subscribe to updates.
Mm-hmm.
And then you could send, whenever something is put into the message table,
okay.
you get a notification from Postgres and you just send it back to your client. And then you have everybody connected.
Oh, nice. Interesting.
We have a message from Wolfgang. What do you think? How it compares to WebSockets?
Yeah.
Yes. So the good thing about it is it uses HTTP2, as I said before. So it inherently, basically every request is already kind of like that, because it only uses the single connection. And instead of WebSockets, which is built on top of HTTP, it directly comes with this idea and implementation. And I don't have to do a lot of things. I don't have to add another library or so. Just works like that. So that's a nice thing. And obviously, again, you have the very small messages, which could be especially interesting when you send a lot of them. Like you said, stock data also. Yeah. I don't want in stock data, you will probably have like every data point looks the same. I mean, how would you represent it? Either you send an array of values and another array of timestamps and you hope they align, or you send a list of objects and then you always have the same like time, then the value, then the value. Right, and you have this 100,000 times. And with that, you don't have that. So you could really save on that.
Nice. So one other idea I just had. How secure is it?
Yeah, so it's HTTP2. That's by default uses SSL.
So if I have like a transaction I want to take care where I need more communication towards and back to the server, for example, I could do it with gRPC, and the connection would stay open as long as I do the transaction and nobody could read it, right?
Yeah.
I know
so
that would
regarding
be
security, it's just in HTTP 1 you make a couple of requests, which each of them has to be encrypted. So for each of them you have to make the round trips to find your common key. With gRPC or HTTP2, basically, that's just the underlying layer. You just do this once.
Okay.
That's the only difference. Yeah.
Nice.
Okay, guys.
Very cool.
Any more questions? If you like this topic, let us know. Then we might have some follow-up streams.
Yeah. So I finally have some time to go through our chat. I hope Lakeview's still there. So hello and thank you for the follow.
Oh, thanks.
It was a long time ago, but yeah,
sorry,
we're too deep into the topic. So yes, love this topic. Yeah, maybe Wolfgangster, you have to come on the show and do some more with it.
Yeah, I'm not sure if we want to lose that many viewers.
Yeah.
Okay, guys. Then.
All right. That was a great topic for this Friday.
Yeah.
Thank you for sharing.
Thanks for having me. For moderating me.
Of course, always. Always interesting.
Okay. Then see you next time.
Have a great weekend.
Bye, guys.
Bye.